Example 5, part C, we're integrating involving exponentials and logarithmics. Step 1, change the radical into a fractional exponent. We've seen that many times. Unlike the one above, it didn't create a negative exponent because it was already upstairs, but it did create a fractional exponent. All right, so square root of quantity would be quantity to the 1/2 power. This is a product. Now you might think, why don't you distribute this here? But in the order of operations, don't exponents take precedence over multiplication? And also, we can't easily apply that power to the group because of the subtraction. So, that's all the rewrite we could possibly do in terms of using the rules of algebra. There is not a product rule for integration like there is for derivatives. So the hope would be that you would realize you need to do substitution here. This is just a somewhat complicated math expression. So, just like when we did substitution, when we have a quantity being raised to a power, that is usually what we want to substitute. So, we'll put u in place of that quantity, and therefore the new integral, when we run off and do our substitution, would become u to the 1/2 power. And that took place of that. So this is all that substitution that we've talked about in previous episodes, which I hope made sense. As I record this, I haven't had a chance to grade your substitution assignment, but I hope that it went well. Let's now build the dx, which again provides the motivation behind differentiating both sides with respect to x. Let's see, 5 has a derivative of 0. And then this would be what? The coefficient e to a power derivative, e to the power derivative of the power. That was that chain rule idea that we did on the assignment prior to this one. And then we clear fractions. This all goes back to that substitution assignment. And now du would equal, and by the way, since that's all multiplication, you can associate is what they call it. Go ahead and multiply the -3 and the 2. -6 e to the 2x dx. And when you inspect what fell in our lap, you go, cool, we got the dx, which was our motivation behind differentiating with respect to x. And we also got the e to the 2x, cool. Oh no, the number's wrong. -6 fell in our lap. I wanted 4. Big deal. Fix it. Right? So, I think that's an easy one. You would go, well, let's cancel out the number that fell in our lap. It's over 1, right? So let's put 1 underneath it. And let's put a 4 in its place. And look, I get it. You silly man. 4 over -6, that's -2/3. I usually put the obvious one over here so it shows me it made this, and then if it reduces, those are the same number. We're multiplying both sides by the same thing. All right? So this side becomes -2/3 du, and this is killed the 6, replace it with a 4. 4e to the 2x dx. Would you look at that? Everything else that's in the original integral has now been constructed, if you will. So 4e to the x, 2x dx, whatever I tried to say, that's this. So in our new integral, this new one that we hope will be simpler, this new one that we hope will be easier to integrate, there you go. So this is back to that substitution assignment. Oh, that's easy. The integral of a power rule. All right, now let's remember the -2/3 that had to be part of this. And then don't you add 1 to that. So 1/2 plus 1 is 3/2. And then instead of putting that over 3/2, n plus 1, n plus 1, just remember we invert and multiply it. So division by 3/2 is the same thing as multiplication by 2/3. This would be the antiderivative of that. And this number just happened to be out in front. Plus c, indefinite integral. Let's clean it up a little bit before we run back to our x. So that would be -4/9, just straight across. It's arithmetic. Did you like that face? All right. And there you go. And I miss seeing your reactions to my weird stuff. And So these questions are worth a couple points apiece, but you know, in theory, I'm supposed to count the whole thing wrong if you don't do this. Substitute back, so -4/9, the expression that u took, look, we're plugging this back where u is, right? 5 minus 3 e to the 2x. Remember, we always go back to our x. 3/2 power plus c. That quantity went back in for u, right? So we replace it, integrate, go back to our x. So there's that one. Not sure what else to say. Let's enjoy a few more, shall we?